Hello everyone, my name is Roy Jafari and I would like to welcome you to another video. In this video we're going to focus on the pesky p-value. If you watch this video, which is going to be a very short one, you're going to be set as far as understanding and interpreting p-value for the rest of your life. You don't want to miss it. Let's get started. Alright, so when we talk about p-value, it's not some mysterious number that's been somehow calculated and we just need to compare it with alpha, 0.05. P-value is a probability value. So that's one of the first things you want to keep in mind always, that p-value is a probability value and it has all the characteristics of any probability value, which is it's between 0 and 1, and it basically talks about a likelihood of something happening, right? So that's the first thing. The second thing is p-value is basically calculating a probability value given a null hypothesis and a sample and a random sample, right? So the p-value is always calculating this. It doesn't matter the type of test you are using, hypothesis testing, t-test, it's regression, ANOVA, whatever testing you're doing, p-value's definition is always the same. If the null hypothesis is true, p-value is the probability of this sample happening. One more time, right? And let me just read it from this one. If the null hypothesis is correct, the probability of this sample happening is p-value, right? So this is a sentence you have to understand and take it with you for the rest of this video and for the rest of your life, right? So pay attention. A p-value is connected to two things. You need to have a null hypothesis and you need to have a sample. And p-value is the probability of this sample happening given the null hypothesis being true. That's p-value, right? So let's look at an example to understand it better. So, like I said, we're going to take this, for the rest of this video. If the null hypothesis is correct, the probability of this sample happening is p-value, right? So let's say our population is this one. It's a population of the United States of America. Let's say population of men and women. So in this population, we are interested in, let's say, this null hypothesis that the average salary of men and average salary of women is the same. Like the null hypothesis is the mu of m. Let's say this is the average salary of men, and the mu of w, the average salary of women, is the same, right? So if we could afford to go grab the information of the whole population, right? Sometimes we can, and most of the time, because it's too expensive, we cannot. We resort to a random sampling, right? So once we have our null hypothesis, and now we have to do a random sampling. Let's say we do this random sampling, and it turns out in this sample, right? So when we do random sampling, we pick these small chunk of the population, randomly select from them, and in this random sample, right, we see, this is our observation. Right now we observe our sample, which we picked randomly. Let's say, for instance, we see that the average of this sample, their average salary is, for men is 75.2, and for women is 65.9, right? So now we have a null hypothesis and we have a sample, right? So now we can calculate our p-value. Let's say our p-value comes out to be 0.00112, right? So let's read our sentence again. If the null hypothesis is correct, which is the average salary of man and woman in our population is the same, then the probability of this sample, we pick this sample and we see this, the probability of this happening is 0.0012, which is a small probability. What that means is, right, if we pick something from our population, if we do a random sample, we would expect the random sample to somehow be similar to what's happening in population. And the fact that the p-value, the probability is small, it does not give us sort of like insurance, or it does not give us the security of knowing that the null hypothesis is correct, right? So that is the reason when we see p-value smaller than alpha, basically p-value is a small values, like the probability is small, we don't say we are proving the null hypothesis is incorrect. We say we do not have enough evidence that the null hypothesis is correct, right? That's the reason we use those types of language, right? So that's p-value. Let's kind of look at the reverse side of this. Let's say, what if the woman's salary and men's salary like kind of changed? Men's salary's average in the sample was 75.2K, and woman's salary on average yearly was 75.9K, right? And when we do the p-value, let's say on this one, the probability value turns out to be larger. This means if the null hypothesis is true, which is the average of man and woman are the same, right? And we do this sample from the population, the chance of this happening, this sample happening, we're doing a random sample. The chance of this happening is 0.76, which is a large probability value. And in this case, we don't have enough evidence to reject the null hypothesis, right? Because if we want to be able to reject the null hypothesis, when we do the random sampling, we want the probability to be small. And that's why we use that kind of language. We do not have enough evidence to reject the null hypothesis. So, for the time being, maybe we accept the null hypothesis. So, as you can see, with this understanding, you don't need to worry about the pesky alpha 0.05. You can just look at the value of p-value. It's a probability value. Pretty sure you have intuition about what the probability value is. And knowing this sentence, if the null hypothesis is correct, the p-value is the probability of this sample happening. You can do your interpretation of any p-value of any test for yourself.